Let's take a look at what is Bayesian inference. Here is a photo of me, and I want to ask you to guess which year was this photo taken. And there are 4 answers. Please choose one of the answers. While you are making your decision, I believe most of you or all of you are doing Bayesian inference. Actually, as humans, we naturally do Bayesian inference frequently. The fundamentals of Bayesian inference is Bayes' rule. We know that given data x and parameters theta, we can write their joint probability in 2 ways. And after we eliminating the joint probability, we have the Bayes rule like this, which you should have already learned. We know that probability of theta given x is called posterior, and probability of x given theta is called likelihood, and probability of theta is called prior, and probability of x is called evidence. So when we said probability of theta given x, that means we fix x and consider theta to be random. And when we looking at the likelihood, we fix theta, that's conditional theta, looking at the randomness of x. So these 4 terminologies are fundamental concepts. So prior probability is the probability of the model before the data is observed. Posterior probability is the probability of the model after observing the data. And the likelihood is the probability of observing a data point given a model. So here we consider the model to be fixed and consider the data points to be random. So this likelihood actually is examining the compatibility of the data with the given model. And lastly is the marginal likelihood, which is also called model evidence or just evidence. This is the probability of observing a random data point under all possible model variations. We will call it evidence mostly in the remaining of this lecture. So when we do Bayesian inference, we want to formulate a generative model. Firstly, we will try to write down the likelihood, the probability of data given a model, given a set of model parameters. And we will also need to write down the prior distribution for the model parameters. And then we will observe some data. And after observing this data, we will update our beliefs based on these observations and consider the prior state of the knowledge. And this gave us the posterior estimation of the model, which is proportional to the product of likelihood and prior distribution. So that is Bayesian inference. Next, let us apply Bayesian inference to our fundamental machine learning problem, linear regression.